we need to look at the difference between what we call terms, like terms, coefficients, and then we need to figure out how to combine them. Combining them has a lot to do with this like term stuff, okay? So if we gave ourselves some kind of expression here at the top, let's, it doesn't matter what it is, 2x squared minus 3xy plus 4x plus, I don't know, 5xy minus 3x squared plus 2x plus 1. So terms are separated by addition and subtraction, and they always take the operation that's immediately to its left, whether that's addition or subtraction. That will determine, the operation will determine if it's positive or negative. So my first term right here would be 2x squared. The next term would be this negative 3xy. And then the next term would be considered this positive 4x. And then the next term would be this positive 5xy. And then we got this negative 3x squared. And then we got this positive 2x. And then finally, this is a term which is considered a constant, which means it's just its own number there. So how many terms did we have? And we could have looked at that earlier, right? We had 1, 2, 3, 4, 5, 6, 7. 7 terms. So like terms have to have the same variable, and the variable has to have the same power or exponent. So, for example, like this first one, here we've got an x squared. This has an x, this next term here has an x, but it doesn't have an x squared. So even though it has an x, they're not considered like terms. The 4x as well has an x, but it's not x squared. So they are also not like terms. Another xy, that's no good because the x is not squared. Here we've got a negative 3x squared. Well, that one is a like term. So in terms of like terms, we got a 2x squared and negative 3x squared. That's correct, yeah. That's a great question. Whether they're positive or negative does not determine if they're like terms. What does is the variable and the exponent of the variable. Now, each term that is a like term has to have the same variables as well. So like this negative 3xy, we have to find another term that has another xy. And again, those have no exponents with them that we can see. They do have phantom 1 exponents, but we're not concerned with that. So the negative 3xy is a like term with this 5xy. And then we've got that 4x, which is a like term with that 2x. The 1 is just a number. It has no variables. If there were any other numbers by themselves, then it would be a like term with those, but it's not considered a like term. Coefficients. Coefficients are numbers that are being multiplied by some variable. So if we just looked at the like terms, for the x squareds, we've got a 2 and a negative 3 there. Now notice I'm not including the letters. The coefficient is just the number. For the xy's, we have another negative 3 and then a 5. And then for the x's, we had a 4 and a 2. Again, the 1 is not considered a coefficient because it is not being multiplied by a letter. So why is this important? Well, we're going to be simplifying expressions in this section, and we have to be able to identify the like terms to combine them. So for example, if I wanted to simplify that expression above, then I would look at my like terms. I've got those x squareds in red, right? So for the x squareds, let me put that down here, we had a 2x squared and then minus a 3x squared, right? So we're just looking at the x squareds. What's 2 minus 3? -1, right? And then let's look at the xy's. Now notice I'm not putting addition or subtraction there yet, and you guys will see why, hopefully. So we had that -3xy, and then that was a positive 5xy. So we really treat that as -3 plus 5, which would be 2xy. And that 2 is positive, so we make that a plus 2xy. And then we've got the x's. We had 4x, and then a positive 2x. And 4 plus 2 would be 6x's. That's a positive 6. Now, of course, we had that other constant, which we'll throw in there now. And this would be considered the simplified form of the expression above. Now, later on, it's possible that they may require this to be in some type of order, descending order specifically, but we're not concerned with that here. So if you wrote this in some different order, 2xy minus 1x squared plus 6x plus 1, that doesn't matter to me. In fact, we don't really even need that 1 there. It's okay for me if you put it there, but I don't know if the homework will. So, but to me, it's all good. So we need to simplify by adding and subtracting like terms on these. Number 2 has only a values, okay? So there's no other variables or letters that we need to worry about in terms of like terms. So we're just going to combine these all. All we have are a's on this. So we got 12 a's plus 5 a's. Oh, that's not plus, but minus 2 a's. So 12 plus 5 minus 2. 12 plus 5 is 17, then minus the 2. That gives us 15 a's. And there's our answer. So on number 5, let's identify like terms on this. So right here we've got a -3n squared. Is that a like term with this 3n? Kind of, right? So this n, that's just by itself, has a phantom 1 exponent. So since the exponents are not the same, they're not like terms. So, sorry, that's a little tricky right now, but hopefully we'll get the hang of it, okay? So we can't combine those. Well, are there any other n or n squareds? Nope, there aren't, so we're just going to keep those there. But now we've got m's. In fact, this m and this m have the same exponent, be that phantom 1 stuff. So, really, we're just going to combine 11 and then -3. Of course, this is in m's. So 11 minus 3 would give us a positive 8. And this would be considered the simplified form. This one, they're trying to get tricky, guys, just like on that last one that we did, number 5. Here we've got a 6m squared, and then we've got a -6m. Those are our two terms. Are these two like terms? No, they're not, because the exponents for the m's are different. So this one, as it turns out, just can't be simplified. Well, I think they actually want us to write that. Cannot be simplified. All right, number 9. So we have all of our terms. In fact, some people like to do it like this, okay? They like to just draw lines out like this, just to show the separation of each term. Whether you like that or not is really up to you, okay? It's just a strategy to help your mind see what is going on and how to separate these. So whether you like them or not, use them or don't. It's up to you. So let's identify this first term. We got 9x squared. So we're looking for other x squareds. There are x's, but not all of them are x squared. This is x to the fifth, so that's not a like term. There we go. There's an x squared. So I'll color code this as well. So for x squareds, I've got 9x squareds and then 8x squareds. So how many x squareds do I have? 17, right? 9 plus the 8. Let's move on to the next term here. Here we've got this 2 times x to the power 5. Well, the 3 doesn't have any variables there, no x's, no letters. But this positive 4x to the power 5 does. And it is a like term, so we're looking at x to the power fifths. If I had 2 of them and then 4 of them, I would have a positive 6x fifths. Now that 3 is just sitting there, that's fine. It has no other like terms to combine with, so we'll just write it in down here. And this is the simplified form of that expression.
Obviously.
So number 11 works like that. But you guys remember the coefficients are the numbers in front of the letters. Here we got that minus w. There is a number in front of that letter. Okay, we just don't show it because, again, math people got really lazy showing those. So we made it a phantom one, but we can show it there, just like that. So we have to be careful that that is a negative 1w, okay? So let's identify our like terms, starting with our first one. We got this 3, which is just a constant. It's just a number. So we're looking for any other numbers. I found one. So I really have 3 plus 2, which is 5. And then let's look at our w's. We got this negative 1w and then this 4w. So when I combine these, negative 1 plus 4w's would be a positive 3w. Now again, I'm okay with that. Just know that it is possible that they may want the letters in the front, okay? So they may require you to write it like that. I hope they don't.
In the homework.
So this wants us to simplify by distribution. And we got a plus 5 times 3c minus 1. So in other words, it's this. Let's just look at this part right here for now, okay? We're just looking at 5 times 3c minus 1. Now remember, each term takes the operation to its left. So see how this is plus 5? I'm distributing then into this parentheses a positive 5. In other words, again, we have to remember what multiplication is. We've got 5 groups of that stuff. So in other words, I've got 5 groups of 3c's. So if I had 5 3c's, how many c's would I have? Yeah, 15, right? Now again, knowing what terms are, this is a negative 1 here. If I had 5 negative 1's, how much would I have? How many negative 1's would I have? Well, this one would be negative 5 right there. Yeah, you're good.
I'm looking at the number 15.
Yeah, you're okay. I do that all the time, actually. So, and that was a positive 15c. So this is my new expression right here. Now, I did skip a step. I won't do that in the next one. So distribution is usually shown with these rainbow kind of things. And rainbows are nice. They're very pretty. In fact, double rainbows have been known to make grown people cry, and that's okay, too. Everyone's seen that YouTube video, right? All right. So now I'm just looking to combine like terms to really fully simplify this. Here I have a constant, number 8, and then this, again, it's going to take the operation to its left. So if I combine 8 and negative 5, I should end up with 3. This positive 15c has no other like term, so I'm just going to make that a positive 15c. And that would be my simplified expression. So that's a negative 2y minus 6 plus 10. Now there's a couple ways we can look at it when it shows no other numbers there in the front, is that we can say that the negative represents an opposite. So we could say, what's the opposite of 2y? Negative 2y. And then right here we have minus 6. So what's the opposite? That's the negative of minus 6. Yeah, that'd be a plus 6 right there. And then we got this plus 10. Now, either way you look at it, it won't matter, but I'm going to show you guys another way to look at it. Just whichever one you like the best, then do, okay? So I'm going to make that a negative 1. Now I can distribute that in here into the parentheses. And what operation is distribution? Yeah, the range. Well, it's multiplication. Very good. So we're really just multiplying negative 1 by all of these. And negative 1 times 2y will still give us that negative 2y. Negative 1 times negative 6 is positive 6. So no matter which way you do it, it will work. The negative 2y has no other terms to combine with, but I've got this 6 and then this plus 10, which when I combine I get positive 16. And that would be the simplified form. All right, so 17, we got 7a minus negative 3a minus 2b. So in this type of situation where there's a term in front of that, subtract the parentheses, that's when I really like to see that as a negative 1. So distributing that into the parentheses, now again, if you looked at it as opposite, it's not going to make any difference. So I got negative 1 times a negative 3a, and then we had minus, again I look at that as negative 1, but now times a 2b. Again, if you don't like this method, use the other way. Think of it as opposites. It won't matter. So we'll say that's 7a plus that stuff. Now when I combine these, when I actually multiply them, I got negative 1 times negative 3a. So the opposite of negative 3a would be 3a. And then we're going to minus this. And I got negative 1 times 2b, which would be negative 2b. And we got this minus the negative stuff, so again, I'm going to change that to plus. Well, I've got these a's. I've got 7 a's and then 3 a's. That's going to combine to give us 10 a's. And then we just got this plus 2b. There was nothing else to combine with for that. So 10a plus 2b, that's what I'm going to stick with. Let's look at 19 as well. So on this one, I'll skip that step because not everyone needs it. I'm distributing this negative 4 into the parentheses. So in other words, I have negative 4 sets of 3x plus 2. Well, negative 4 times 3x would be negative 12x. And then the negative 4 times the 2 would be negative 8. Now notice, I didn't put plus negative 8. I just made that a negative 8. So I made that a minus 8 right there. Now I'll distribute this. This is going to be distributed as a negative 4. So negative 4 times 3x, again, negative 12x. And negative 4 times 2 is negative 8. All right, from here I'm just looking to combine like terms. Here's a negative 12x. Here's some more x's. Negative 12x and another negative 12x would be a negative 24x. And here I've got a negative 8 and then another negative 8, which combine into negative 16. There it is. All right, so on 20, on one of these parts we're distributing that negative x there, which it really isn't as bad as you may think. So let's look at distributing the 4 first. Now it's usually common to distribute in only 2 parts, but in some cases a set of parentheses may have 3, 4, or even 5 parts. This one has 3 each, and that's okay. So 4 times x is 4x. And then 4 times xy would give us 4 xy's. And 4 times xyz would give us 4 xyz's. But now we stumble on this, again, that would be considered a negative x, which when I distribute, negative x times 3 would give us negative 3x's. Negative x, I'm treating that as a negative 2y. So negative x times negative 2y would be a positive 2xy. And then finally distributing it to the 3yz would make that a negative 3xyz. Now I just need to look for like terms, and I've got this 4x with this negative 3x, so when I combine these, I get a 1x. Again, it's not necessary that you put the 1 there. I'm okay if you do. I'm not sure if the homework will, though, so just be careful. Well, then I've got these xy's and these 2xy's, so when I combine them, 4xy's and 2xy's would be 6xy's, which are positive. And then finally, our xyz's, 4 of these and negative 3 of those would give us a positive 1 xyz. And again, we don't really need to show the 1 there, but you can. That's it. Pointed that out. So I did that out of habit. Now again, I don't really care about the order because yxz is the same to me. Formally though, we're supposed to put them in alphabetical order.
Okay.
But again, I don't care. So if I saw x plus 6yx plus zxy, that's not going to matter to me. Because it shows that we know how to combine the like terms, which is what we're looking for here. Not can you put these in alphabetical order.